Hello, and welcome to our Saga of Performance Battles webinar. If you have any questions during this webinar, please use the Q&A section, and at the end we will address them. You also have a question for us, from us, Paul. Please provide some answers for us. So let's begin.
Hi, my name is Irina. I'm a Java developer in Yonder starting from 2017. And since then, I worked on 2 projects. I got involved in mentorship programs, and I also like debating technical experience with my colleagues, since for me, that is one of the best ways to grow together with your team. In my spare time, I like walking in nature, and I also like meeting with friends, and I have a passion for photography.
My name is Cătălin. I'm a Java developer for more than 8 years. I'm interested in performance and also modeling of the applications. I'm passionate about sports. All kinds of sports, but lately I've been more interested in mountain biking, so fresh air sports. Today we'll present you the setup of our Saga, meaning the application and also the team that we had. We'll discuss about the performance benchmarking, which we've done, and the results obtained for that. Also about what happened before and after going live. And in the end, we will present our conclusions about this. So the setup. We had a 40 years old Java application having a Swing interface. So it was a desktop application, and the data was stored in a flat file database. Okay, being a 40 years old monolith means that the functionality is pretty coupled between them and difficult to maintain. Also, as user experience is pretty difficult with the desktop application, it's limited. And at the database level, flat file database is pretty difficult to work with. It's difficult to read and maintain. What we had questionnaire application, and we decided to reinvent this functionality and break it in microservices architecture with Spring Boot next to our monolith. On the graphical interface, we decided to use an Angular application because this helps us improve the user experience and also to add new functionality for the user. On the storing part, we use the relational database, DB2 in our case, because it's easier to develop on, and also the maintenance, it's easier to be done. So what we did next, we put together a team, a mixed one. In this case, we had 3 backend developers, 1 front-end developers, quality assurance, quality analyst, and business analyst. We took that team and we went to a private hackathon at our client in their offices. We stayed a week there. During this time, we had a lot of meetings, also coding, discussing. After this week spent there, we managed to have a POC. In this POC, we managed to open an embedded application, an embedded web application in the existing Java desktop application. The components managed to communicate with each other via message queues. Storing of the data was done both in COBOL application and DB2, or relational database. We managed to implement also the UI design and define the main flows of the module. Okay, so we managed to do the POC. After that, we started to go to the MVP. To reach that, we had to match the expected user behavior for the application, for what we delivered, and also to make sure that the system is stable and resilient to our changes. In this development phase, in the development of the application, we had multiple development phases. Since we work agile, we had a lot of meetings with the SIG being a special interest group, which gives the requirements of the product, and they will be the first one to use the product. One of these meetings was actually at their location, so we had the visit there, and we managed to actually see the reaction of when using our module, our application. As far as I see in the pool results, most of you did performance testing when something didn't work as fast as expected. It was similar in our case. We had two periods, let's say, when we did this before releasing to production, and when something was not right in the application.
Indeed, like Catalin mentioned, after finishing the grid functionalities for the MVP, we started thinking about the performance. What would be the best approach to assess the viability of our module once it will reach production? So from that point of view, one of the metrics we had as objective was to support at least the previous years of activity or more. Having that in mind, we started analyzing the implemented flows. We took into account the way the end user were supposed to use the module and designed some scenarios to test the performance. Performance testing is the software testing process used for assessing speed, response time, stability, reliability, scalability of a software application under particular workloads. The main purpose is to identify in order for later to eliminate possible performance bottlenecks. The most common types of performance testing include load test, which checks the application ability to perform under anticipated user workloads, stress testing that involves analyzing the application under an extreme workload in order to identify breaking points. Endurance testing is done to make sure the software can handle the expected load over a longer period of time. Spike or peak testing checks the software reaction to a sudden large spike in the load generated by the user. And not to forget about the volume testing, which tests the system's behavior when a large volume of data is inserted into the system. And scalability testing, which determines the application's effectiveness in scaling up if an increase in user load happens. In our case, we decided to use these approaches based on a sequence of steps that a normal user would use the module under and run it under the previously mentioned approaches, strategies. For that, we started by defining a load test scenario that would help us achieve our objective, specifically to support the previous years of activity, and after that, to also test the system under the rest of the performance testing approaches. To create the test for us to run, we chose a Gatling framework, which used Scala as a programming language. And we preferred this tool because it gave us an easy and highly descriptive way to write the test scenarios using the code, and also generated some pretty detailed and expressive reports regarding the results of the test. Also, great. It's free, it's open source, and it has a pretty big community behind it, where we could find the good practices, examples, or even answers on the issues that we encountered. We've tested and we can confirm that the results of the tests generated by Gatling could be easily understood by both technical and non-technical members of the team. The scenario we designed to run under the various performance testing approaches was made to assess quality metrics such as response times, resiliency, overall user responsiveness, system stability, and maybe to find the breaking points of our modules. There's a thing that happened. This was the reaction that our project owner had when he saw the first results of the first load test we ran. What do you think was his reaction, or why do you think that happened? We have wished for him to be super surprised by how fast the application was working, but the results weren't so great. This is the report generated by the first load test we made. The 4 columns under the indicator section describe how the response times were distributed among the standard ranges, and the 4th column marks the failed requests in red. In the lower section, there are some statistics such as minimum, maximum, average response times, and also standard deviation and percentiles globally and per request for each step of the designed load test. As you can see, the test scenario involved a series of 7 steps describing a sequence of the actions that the user could do in the application. And this one has been executed 900 times. The 7 steps were actually REST calls towards our microservices, and some of the steps were using data received as a response from a previous step. And we wanted to do this specifically because we wanted to map the way a module worked in reality. We checked this results, and we got to some conclusions that some calls were not responding fast enough. So all the subsequent calls would cause failures due to timeouts. That from a certain moment in time, we saw that all the calls were not responding anymore at all, leading to only failed results, which are marked here under the knockout column. And we got to the conclusion that besides the stress test approach, a load test scenario must be refined so to match a true user's behavior. We had to add things like pauses between requests or to diversify the sequence of steps, just like a true user in production would do. Having those in mind, we identified some areas to investigate in order to assess the current application state and to make the improvements in order to get rid of these bottlenecks. As Katalin mentioned, this module has been developed over a microservices architecture, and this implies multiple aspects of the system to be addressed. Firstly, the communication in the application should have smaller response times and also passing only well-structured data. The memory of the application should be used and released properly. The data involved into the business logic should be managed via efficient data structures and algorithms. And last but not least, the structure of the database where we persist these questionnaires should be refined so that the storing and the retrieval mechanisms would be most efficient. As an auxiliary aspect of the performance benchmarking strategy, the team assessed alongside the stakeholders the existing scenarios, and we designed more close to reality load tests. We made plans to create and run both everyday activity load test and also extreme usage scenarios. So we know exactly how it will act when a true user will get to the application and use it every day. So we decided to get to the grid and get to work. One of the most important areas we addressed was the memory usage and the management of each microservice involved into the module. This area was investigated because we saw that from a moment in time starting the test, all the requests were failing. Searching the cause of this, we found out that one of the microservices involved in the logic was that was managing important data would just freeze after a moment in time because the memory wasn't released properly by the garbage collector as we would have expected. So as a result, the microservice would be able to aggregate responses for the calls only for a limited period of time. And after that, all the test scenarios would fail. And this wouldn't be acceptable in a production scenario. So to study this matter, we needed a memory profiling tool. We went for JProfiler as we considered it to be the best approach as it had a lot of metrics integrated, presented in a very easy to follow way. We could trace and record the evolution of the system in time, and based on that, we took some actions. Some metrics we checked were the garbage collector activity, the active threads, the object instances in memory, the active session in communication, and so on. The most effective actions we took for our case was firstly improving the connection management. We had to make sure that all internal and third-party connections were closed when the action completed and they wouldn't remain active in memory. We audited the data we bring and keep at a certain point in the main memory because an action that helped a lot for us was to get only the necessary data. So we refine and create a better model for that, for the aggregation approach to be the best. And also we improved the way we use data structures and we chose the most efficient ones for each specific case. Another area of improvement that led to great decrease in response time was the investigation of the database we were using at the time. As the database structure was first set during the hackathon, which was for the functionalities from the POC, we knew we had to revise it at the moment when we started the benchmarking process, because along the development phases, the most amount of time was dedicated towards adding functionalities and less on reassessing how optimal were the database details. Seeing the results of the test was a good enough signal we had to do something about it. The team started analyzing the database structure, the execution trees, the indexes, and the fetching strategies used. We took the most used queries and commands of the module. We studied them and also studied their execution tree and their cost and applied query performance tuning. Like so, we found better ways to write the queries and we defined better indexes. Further, alongside the normalization of the existing database structure, the amount of data retrieved was reduced to the minimum. Needless to say, these optimizations made the storing and the retrieval mechanisms from the database way more efficient. Notably, both the communication between internal components and between internal and external ones has been addressed. Having a microservices architecture that achieves communication via a message broker, the data passed through the message queues needed to have an optimal structure and volume. Further, our system should have an efficient interaction with external parties also, so the response return can be used in order to complete the application flows. This also implied the structured information passed between these components to be minimum. We analyzed the data needed for the business logic and redesigned our data transfer structures. Also, We had great technical stakeholders from the third party side, and together we've been involved so to refine the communication contract between our applications in order to optimize it as much as possible. At the end of our efforts of optimizing the various aspects of the module, we saw a great improvement in the response times and the whole application behavior. The system performed way better under all previously defined scenarios, and the overall user interaction felt way smoother. These images are the results of the load test before and after the implementation of the improvements. As you can see in the second image, the majority of the response times were under 800 milliseconds in green. Also, the test scenario was diversified and now was composed of 12 steps, which were repeated 2,400 times. Also, no failed requests, finally. And again, the results are pretty descriptive. The time of storing a questionnaire was decreased 33 times. The retrieval of the list of available questionnaires 115 times, and we could open a questionnaire to be filled 173 times faster. Currently, these results and also the results of the other performance testing approaches such as stress, peak, or endurance testing are now a reference point for us in the future development phases of the module. Here in the second picture, you see the load test, which was run for about 30 minutes on the expected user load from production. And we also managed to do a stress test where we doubled the expected load from production, and we also didn't have any failed steps. Also, the endurance test featured a 2-hour-long load test, and we're proud to say that in that case also, we didn't have any failed load test steps. Now, how do you think our project owner reacted to the results? Needless to say, he was extremely happy with the results, and the team also was very proud of the work we've done together.
So we got to the big event, the release into production. But before that, we had to make sure of some things. First, we had to make sure that all the flows were running smoothly and that we had covered all the desired functionality from our customers. Beside that, we had to make sure that the performance tests were running smoothly and they were green, as Irina presented. On the other side, we had to enhance the logging of our application, on which we created some Splunk dashboards. After going live, we start monitoring the application to make sure that we don't have any problems in production, and to make sure that we get to them fast enough if they appear. Another thing that was left to do after going live, it was to create some Splunk alerts. In this way, we will get notified faster if something goes wrong. Some examples of dashboards or metrics that we used was the number of questionnaires created or opened in a certain amount of time, how many of them were actually completed or on different clusters. Also the errors dashboard, because we have to make sure that if everything occurs is noted, is catched. But another metric was the response distribution time for some answers, which took more than expected duration. Okay, so after The life after production started with 2 months of active monitoring. This meant that 2-3 times a day we were looking into the dashboards to check if there are any problems there. After that, we went to a passive monitoring for about 4 months. And this passive monitoring meant about 2-3 times a week, checking the dashboards for that. In this period, we managed to get the expected behavior, the expected load into production, about 4,000 questionnaires a day. And by now we have more than 360,000 completed. During this period, we had some small fires because, yeah, it's almost inevitable to go perfectly into production. But the good news was that those fires were not related to performance. They were related to the communication with some third parties. Also, in the same period, we kept in touch with our customers and got the feedback from them. And we are pleased that they are using our module and they really enjoy it. So our conclusions about this saga of performance battle. It was very useful for us to have an incremental development phase where we developed the functionality, we tested it, we performance tested it, and also we got the feedback from our end users. Like I mentioned before, we had several development phases where we got the feedback from our customers, and this assured us that we delivered the desired application into production. It was very useful for us to have relevant logging and monitoring in production, like I mentioned, the dashboards, because we use that not only to track the bugs or the problems in our application, but also to see how the user, how the end user use our product. Because we developed the product with some specification and some usage in mind, but the end user feels different or has a different opinion than our and uses sometimes in a different way. Performance testing was one of our best weapons in this, because we did the test based on the end user behavior, and we managed to track all the actions that they do and the time between each request they send or each action they do in the UI. We managed to cover the resources used in the application. We managed to cover the communication between our modules, and that assured us to give a stable product and also reliable to deliver it in production. Sorry. On the other side, what we advise you that you shouldn't do is to ignore the feedback from the end users. It is really important to have a feedback from the end user, because you know that you delivered what they need. And these days, it's mandatory to deliver to accomplish the needs of our customers. Next, we started as a hackathon, so it was a POC developed fast, and we didn't invest too many time in performance at the beginning or at a very early stage. This helped us in involving much time in our customer needs and less time in the performance in the first phase. And then when we made sure that they get what they need, we cover the performance tracks. You shouldn't miss the performance metrics. There are a lot of metrics to to observe related to your application. Like Irina mentioned, the memory, the connections, database, also the logs, the tracks from the application, because logging is very useful in application and that can give us precious information about how our application works. And last but not least, even though we as developers don't like to write documentation, it is essential to do that because it makes a ramp up for the team, for example, easier, and also the maintenance a lot more easier. In our case, the team that started the hackathon was not the team that ended it. It changed like 60–70% the team. So documentation helped us very much in this case. So we see a lot of things, we see a lot of metrics, a lot of information which we create, which other applications, helping applications create, but we don't necessarily observe them. So we have to pay more attention on what the application tells us, on what our customers tell us. Thank you. Thank you for the presentation.
And don't forget, we also expect the questions from you. If you have any other questions which we cannot, for example, answer right now, we can answer it anytime. You just have to contact us at the mail addresses in the lower part of this slide.
Katalin and Irina, you have 2 questions in the Q&A in the answered column.
Let me also. Okay, I'll read it. How do you explain the improvements and the time it took to your customer? I assume they expected great performance from the start. Did they have a specific requirement on performance? I think I can try to answer that. Like we mentioned, we had a period of time in which we added a lot of functionality. It was necessary also in their selling process to have some functionality in order to show to the end user. So we took this risk from the start that we might at some point reassess the how the application will work and what we would expect. Also related to the second part of the question about the specific requirements on performance, yes, we knew that we must equal the expected behavior from the previous years that the, let's say, sister modules of the ones that we implemented had. So we knew about those and we took them into account when we created and when we designed the load test scenarios. And while doing the improvements, we didn't stop until we achieved that requirement. I think Katalin mentioned about something related to 4,000 calls in a normal day with some variations between the working hours. Okay, and I don't know if
There's another question that...
Yeah, related to the tools used for performance testing, we used the JProfiler, as Irina mentioned, to get the garbage collector activity, the memory, the connections, and also related to the database, we analyzed the execution trees for the indexes, also the fetching strategies. We used JPA for this. What else?
We used to monitor, we used Splunk, and we also were able to check the response times because like I think Catalin, you mentioned, we made the refactoring also on the logging. And yeah, we were able to track the duration and the improvements also using Splunk. So I think those were the most yeah, useful tools from the performance measuring part.
On the open section of the Q&A, there are 2 more questions.
Okay, I see one. What did you use to find the parts that needed more attention, like garbage collector, database, etc.? Because we had the microservices architecture, we kind of knew what generic aspects of the application we must take into consideration, and we basically took them one by one. We knew that the database needed attention because, yeah, we started it as a hackathon part, and of course we already knew from the start that we might need to do some checking there. After that, one of the most important, let's say, clues for us that we might have memory garbage collection issues were the fact that everything worked great until a certain point in the load test, and after a certain period of time, one of the services would just freeze. And while checking its measurements, let's say, in checking the memory of that machine and all that, we would see that we had very little memory left. And we actually got to also see that firsthand when we checked with JProfiler, because like I mentioned, it had a lot of measurements, very easy to follow, presented. And one of the things that also JProfiler helped us was related to the instances of objects in memory. We said that we had a lot of data brought to the memory when we only needed like a half of it or just a part of it to achieve the business logic. And yeah, we got a bit, we made a lot of cleaning in that area. So yeah, took them one by one.
You have time for one more question. There's one that goes, have you implemented any mechanism that will prevent or signal you if the application suffers a performance decrease again in the future?
Related to this, like I mentioned, the Splunk alert that we are going to introduce to basically, if something happens in a short period of time, we get emails or notifications on my phone to address that problem immediately.
Since this was short, you have a little time to answer the last question. Have you considered the newer tools like Flight Recorder?
No, for this one, we haven't introduced Flight Recorder, but thank you for the proposal. Personally, I haven't used the Flight Recorder until now, but it's a new thing to learn. Well, I think this is it for today. Thank you for your time. If you have any other questions or suggestions, please don't hesitate to contact us. And have a great day.
Thank you guys for attending.